Most interesting thing in tech, AI data centers in space. The idea seems insane, but it's actually kind of interesting, and the science is pretty cool. All right, so an AI data center needs a lot of things. You need to get all the materials, you need to get a lot of energy, you need to have a lot of cooling, and you need to get the information from the data center to where it needs to go. Let's talk about these different problems. So, constructing the data center, much harder in space. If you want to construct a data center in the desert here in the United States, you put everything in a truck, drive it there, figure out your power grid situation, and you build it. You also have to get permits. In space, you have to somehow get it into a rocket. If it's really complicated, maybe you have to fold it, then you have to unfold it. You have to figure out the array. The maintenance is really hard. If something breaks, you can't just send a TaskRabbit out to go and fix it. Much harder logistical problems. The heating and the cooling. This to me is the most interesting one. We think about space as dark and cold, but it's actually kind of light and hot. The sun's solar energy gets much more directly to space than it does to Earth because there's no atmosphere in the beginning. So solar power works better up there, but it's really hard to dissipate heat. Obviously, you can't use water cooling. You have to figure out different forms of cooling, and that's quite hard up there. So some things are easier, some things are harder. There are other logistical problems that you don't have on Earth. For example, solar debris flying around, crashing in to stuff. Then there's the question of how the information gets up and how it gets down. You may beam it from your data center to a bunch of orbiting satellites, then from the satellites down to Earth. You could try to beam it directly from the data center down to Earth. You have a separate problem there. Most likely, in anybody's time frame, you use it first for training and then for inference. Inference is where you have a much higher demand for quick responses. So that's a very tricky thing. Now, there's also the question of permitting and regulations. One of the things that the space advocates talk about is that it's really hard to build on land. You have to go through government agencies. There's NIMBY problems. Space is just space. It seems insane to me that it would be easier to build way up there than it is down here, but maybe it is. Maybe it's easier than in New York or California. Building in heavily regulated places is, of course, very hard. Now let's get to the time frame. So Musk says 30 to 36 months. Bezos gives a much longer time frame. Other people say this is ridiculous and will never happen. Now, Musk has historically exaggerated the timelines. In 2016, I think it was October 2016, he said by the end of 2017, you'll be able to get in a Tesla, full self-driving, drive from San Francisco to New York, park itself. That, 10 years later, still hasn't happened, though we are getting a lot closer. So you could just say he was overambitious. But here's the thing to remember. Musk is often right on these timeframes and what is going to happen. He also talks his own game. He has the SpaceX IPO coming. Obviously, he wants that to do exceptionally well. And if we do end up training AI data centers in space, I don't think people appreciate how much Musk wins. Because to get everything up there, you're going to use SpaceX. To get everything down, you're going to use SpaceX. And this is why the real indication that this is going to happen is when you start to see the other AI companies launching satellites and trying to get parts of that infrastructure so they're not wholly dependent on Musk, who controls so much of the gateway to space and the routes downward. So my guess, it kind of makes more sense than I would have thought a few months ago. I don't think it's going to happen on Musk's time frame, but it's definitely today's most interesting thing in tech.